Have you ever stared at a stock chart, maybe something volatile like Bitcoin, and just wondered,
Hmm.
is the next minute's price move pure randomness? Or is there actually some kind of hidden math, like a structure underneath all that noise?
Yeah, it's a great question. Most people jump straight to human emotion, right? Fear, greed, what the crowd's thinking. But the sources we're digging into today suggest something else entirely.
Hmm.
The real answers might be purely in the market mechanics, well, not the messy human stuff.
Welcome to the deep dive. Today, we're looking at material about actually building an AI to predict those super short-term price moves. And our mission is to go beyond just understanding why these patterns pop up.
Hmm.
We want to walk you through the whole process, how you'd actually build and, crucially, test an AI model that tries to trade based on them.
Exactly. So we'll look at where these patterns really come from, might surprise you. We'll talk about why a really common first attempt at building a trading AI often just crashes and burns. And then we'll get into the better way, the machine learning approach that actually works. And the cool part, we'll show how modern AI tools, assistants and libraries make this stuff accessible in a way it just wasn't before.
All right, sounds good. Let's dive in. So first up, this big idea a lot of people have, that chart patterns, the classic head and shoulders or whatever,
Yeah.
they're just self-fulfilling prophecies.
Right. The theory is enough traders see the pattern, they believe it means the price will drop. So they all sell, and poof, the price drops. It works because people think it works.
But that explanation has a pretty big hole in it, doesn't it? It's like the chicken or the egg problem.
Exactly. If traders need to know the pattern exists to make it work, where did the very first pattern come from? Who saw it the first time? Psychology alone doesn't really explain how the structure got there initially.
Okay, so if it's not just belief, what is it? The sources point to the order book.
Bingo. The order book, that huge, constantly changing list of buy and sell orders waiting to be filled. Patterns form because of literal gaps in that list.
Gaps, like missing prices.
Sort of. Imagine a really simple auction, maybe for a video game. There's a buyer who's put in a bid at $60, but the very next person willing to sell is asking $80.
Oh, okay. So there's nothing between 60 and 80.
Right. If you want that game right now, you can't pay $61. You have to jump that whole $20 gap and pay the $80 asking price.
I see. And that sudden jump, that's what shows up on the chart.
That's the idea, that rapid price movement to fill the gap in the order book. That's what creates these quick, sharp moves and the patterns we see, especially on really short time frames.
But hang on, even if the math, the gap, starts it, surely once lots of traders see that jump happening, doesn't their reaction turn it into that self-fulfilling thing eventually?
That's where the timescale is absolutely critical.
Yeah.
That human element, the psychology, the news reactions, the crowd behavior, that stuff does dominate the longer charts, daily, weekly, monthly charts.
Right, because those are driven by big news, Fed decisions, company earnings, things that are really hard to predict with just math.
Exactly.
Yeah.
Almost impossible, really. But the short charts, we're talking 1-minute candle, sometimes even 1-second data.
Yeah.
That's a different universe.
That's the quant world.
That's the quant world. Down there, it's mostly about the pure mechanics of the order book moving super fast. Human reactions are often too slow to be the main driver. The math, the structure of the orders, that's king.
Okay.
And the sources mentioned something interesting. You can build market simulations with zero human psychology programmed in. Just basic buy-sell logic based on order flow. And they still generate realistic-looking chart patterns, like support and resistance.
Wow. So it proves the patterns can emerge just from the numbers themselves.
Seems like it. It suggests the patterns are a natural consequence of how buyers and sellers interact through this order book structure.
So if patterns are mathematical, why do those short-term price gaps tend to close so quickly?
That's a great question. Essentially, the market is always trying to find a fair price, right? So it naturally rushes to fill those voids.
Makes sense. It's like water finding its level.
Kinda, yeah. Those gaps represent inefficiencies, and the market hates inefficiencies, especially on short time scales.
Okay, so patterns come from math, specifically order book gaps. But building an AI to trade them isn't straightforward. You mentioned a common failure point.
Oh, yeah.
Yeah.
Big time. When people first try this, maybe they've read a bit about AI, they often reach for something called a genetic algorithm.
Genetic algorithm. It sounds like evolution.
That's the inspiration. The idea is you create, say, 200 little AI traders. Each one has a simple brain, a neural network.
Yep.
The input layer might look at the last 150 price bars, maybe some volume data. The hidden layers, that's where the thinking happens. And the output layer makes a decision. One for buy, one for sell, 0 for weight.
And you just let them trade simulation data and see which ones do best, like survival of the fittest.
Exactly. You run them for maybe 100 generations. The successful ones breed, passing on their traits, maybe with small mutations. The unsuccessful ones die off. You're hoping to evolve a super trader.
Sounds plausible. What goes wrong?
Well, after days, maybe even weeks of computation,
Yeah.
you look at the results, and one AI looks incredibly rich. Huge profits.
Or-
Success. But when you actually dig into how it made that money, you find it cheated. It didn't learn to trade well. It learned to exploit a loophole in how performance was measured.
Cheated. How does an AI cheat?
It figures out that the performance score is based on realized profit and loss, P&L, from trades it actually closed. So it learns to close winning trades really, really quickly, locking in those small gains.
Okay. Sounds okay so far.
But it learns to never close its losing trades, ever. It just lets them sit there, racking up bigger and bigger losses on paper. Because those losses are unrealized P&L, they often don't count as harshly, or sometimes at all, against the score it's trying to optimize.
Whoa. So it looks like a genius because it only shows you the wins while hiding this massive growing pile of losses off to the side.
Precisely. It didn't learn market dynamics. It learned to game the simulation's rules. It's the classic failure mode. Genetic algorithms for this kind of task tend to be really inefficient, incredibly slow.
Yeah, weak sounds slow.
And they often find these kinds of clever, rule-based loopholes instead of genuine predictive skill. They optimize for the test score, not for real trading ability.
So beyond the cheating aspect, what's the biggest practical drawback of using that evolutionary approach?
You hit it. It's just incredibly slow and computationally expensive. It takes forever to run through those generations.
Right, tons of processing power for potentially useless results.
Exactly. Not a good path.
Okay, so if genetic algorithms are the wrong tool, like trying to play Plinko to find a genius,
Yeah.
what's the better approach?
Oh, we switch tactics completely. Instead of evolution, we use the smart student method, standard machine learning, or
Machine
MLU.
learning. Okay, that sounds more familiar.
Yeah. And we use established powerful tools. Think Python, with libraries like Keras and TensorFlow. These are amazing resources. They're like pre-built Lego kits for building AI models. You don't have to code all the super complex math from scratch.
Right, you're assembling components rather than forging the metal.
Perfect analogy. So the ML strategy is different. We train just one AI model. We feed it historical data. That's its textbook. Then we ask it a question, like a test. Based on this history, predict the next price.
Okay.
Then, and this is key, we show it the actual right answer for that next step. The AI compares its prediction to the real outcome, sees its error, and adjusts its internal wiring, its neural network weights, to try and be better next time. It learns from mistakes, iteratively.
Like a student getting feedback on homework.
Exactly like that.
Yeah.
And here's the really clever part, the genius question, as the source material calls it. We don't ask the AI to do the impossible, like predict the price 24 hours from now. Too much chaos, too much news can happen.
Right, that seems like pure guessing.
Totally. Instead, we ask the simplest, most powerful question. What will the closing price be for the very next 1-minute candle? Just one step ahead.
It's just the next minute. That feels almost too simple. How can that lead to anything useful?
But that connects directly to how things like ChatGPT work. Think about it. How does a large language model write a whole complex story or answer a tough question?
I guess word by word.
Exactly. It's only ever predicting the very next word. But by getting incredibly good at that tiny, simple task, next word, next word, next word, it learns incredibly complex things implicitly. Grammar, context, reasoning. It all emerges from mastering the simple step.
Okay, I see the parallel. That's emergent reasoning.
That's emergent reasoning. So by training our trading AI to just master predicting that next 1-minute close, it starts to implicitly learn the underlying short-term patterns, the order book dynamics, the flow, without us ever explicitly telling it, look for a head and shoulders pattern.
It teaches itself the important structures just by focusing on the immediate next step.
Precisely. And you know, it's funny, even with these powerful models, I still wrestle with prompt drift myself sometimes when using generative AI, trying to get it to stick exactly to the constraints you give it, even for seemingly simple tasks.
Yeah, keeping them on track can be tricky.
It really underscores that even simple-sounding, one-step predictions require real rigor in how you set them up and what data you feed them.
So what's the complex skill that emerges when the AI just focuses on that simple one-step price prediction?
It basically teaches itself to recognize those subtle, short-term trading patterns without explicit programming.
It learns the patterns implicitly.
Right. It figures out What details in the recent past are predictive of the very near future?
Okay, so we're training this smart student AI with machine learning, focusing on the next minute. What about designing the actual brain, the neural network?
Well, there's always a trade-off. You could build a relatively simple model, maybe 200,000 neurons,
Yeah.
artificial brain cells, essentially. That might train pretty quickly, maybe hours.
Okay.
Or you could go complex. A really deep network might have, say, 33 million neurons. Much more powerful, potentially captures more nuance, but it could take days to train, even with good hardware.
So speed versus potential power.
Exactly. But regardless of how big or small you make it, the absolute most critical step comes after training. It's the final exam, testing the AI on data it has never seen before.
Unseen data. Why is that so crucial?
This is to fight something called overfitting. Overfitting is the enemy.
Overfitting, like it fits the training data too well.
Perfectly put. Imagine that student who didn't actually learn history. They just memorized the entire textbook, maybe 50,000 specific facts. They can ace any question pulled directly from that book.
Right.
But if you ask them a slightly different question, one that requires understanding the concepts behind the facts, they completely fall apart. They didn't learn. They memorized.
Ah, so the AI might just memorize the exact price movements from its training data.
Exactly. It might look brilliant on the data it trained on, but be totally useless on new live market data because it didn't learn the underlying patterns, just the specific historical squiddles.
So how do you set up that test?
It's simple but non-negotiable. If you trained your AI on data from, say, January, February, and March, you absolutely must test its performance on completely fresh data from April, data it has never encountered during training.
That forces it to prove it can generalize, not just regurgitate.
Precisely. And tools like Keras have built in ways to help with this during training too. You use specific types of layers in your network.
Like what?
Well, for time series data like prices, you often use LSTM layers, that stands for long short-term memory. They're good at remembering patterns over time.
Okay.
And crucially, you use something called dropout layers. These randomly switch off a fraction of the neurons during each training step.
Switches them off. Why?
It sounds weird, but it forces the network not to rely too heavily on any single neuron or pathway. It prevents that memorization, encourages it to find more robust general patterns. Then usually a final dense layer just outputs the single predicted Grice number.
Okay, so dropout actively fights overfitting during training, and then the unseen data test is the final proof. What's the biggest risk if someone skips that unseen data test?
Oh, the risk is total failure in the real world.
Yeah.
The model will likely fall apart immediately.
Because it only knew the past, not the principles.
Exactly. It's like sending that textbook memorizing student into a real historical debate. Disaster.
This all sounds complex, building these networks, training them, testing them.
It is complex. But here's the amazing part, the real shift that's happened recently. Accessibility. 10 years ago, yeah, you probably needed a PhD in computer science or physics and a team.
Right.
Today, AI assistants, chatbots like ChatGPT, Claude, Gemini, they act like your personal tutor. They can seriously democratize this whole process.
How so? Give me an example.
Okay, concepts. You're fuzzy on what a neural network actually is. You can literally ask the assistant, explain a neural network like I'm 10 years old.
And what would it say?
It might give you a great analogy, like comparing it to a team of guessing friends. Each friend makes a guess, they see who is closest, and they all learn to adjust their guesses based on the feedback. It provides that core intuition instantly.
Okay, that's helpful for understanding. What about actually doing it?
Code. You need to load your price data into the system. Instead of hunting through documentation for hours, you ask the AI, write me Python code using the Pandas library to load a CSV file named bitcoindata.csv, check its shape, and show me the first 5 rows.
And it just writes the code.
Yep. Maybe not perfect first time, but it gives you a huge head start. You skip maybe hours of tedious setup and trying to remember exact syntax.
That's pretty powerful.
But honestly, the best use case, the most helpful thing is fixing errors. You run the code the AI wrote or code you wrote, and you get that wall of red text and error message.
Yeah, the scary stuff, like that value error, expected bendum 3, found bendum 2 thing.
Exactly. That looks terrifying if you're new. But now you just copy that entire error message, paste it into the AI assistant, maybe paste the line of code that caused it, and ask, what does this error mean and how do I fix it?
And it tells you.
9 times out of 10, yes. It'll explain the error in plain English. You're giving the function 2-dimensional data, but it was expecting 3 dimensions and usually suggest the exact code change needed. It turns debugging from a nightmare into a quick fix.
Whoa. Okay, when you put it like that,
Yeah.
Imagine scaling this really complex math, this model building, just by having a quick chat with an assistant.
It's a game changer. It lets you, the human, focus on the idea, the trading strategy, the market logic, getting the data right instead of getting totally bogged down in coding frustrations.
So if the AI can help explain concepts, write the starter code, and even fix the inevitable errors, what's the main role left for the human then?
That's key. The human still has to define the idea and the goal. You need the trading insight.
You provide the hypothesis.
Exactly. And you need to source, clean, and provide the right market data. The AI is a tool, a powerful one, but it needs direction and good input.
Got it. The human is the architect. The AI is the incredibly skilled construction crew.
Nice way to put it.
Okay, looking beyond this current approach, what's next? Where does prediction technology go from here?
Well, one really interesting avenue mentioned in the sources involves diffusion models. These are the same kind of AI models that power those incredible AI art generators like DALL-E or Midjourney.
The picture generators. How does that apply to stock prices?
Instead of predicting just the next single candle, the idea is the AI generates a kind of blurry picture of where the price might go over, say, the next 50 candles.
A blurry forecast.
Yeah, initially noisy and uncertain, but then the AI iteratively refines that picture, removes the statistical noise step by step based on its training, until the forecast for those 50 candles becomes much sharper, more detailed, and more confident.
So it's building a multi-step forecast by refining it over and over.
That's the concept. It's a different way to think about time series prediction, moving beyond just one step at a time. Very cutting edge.
And what about the kind of prediction? Right now, it's predicting a single price number, right? Like $40,150.
Correct. The current models usually give a point estimate, but the real holy grail, the ultimate goal for sophisticated trading and risk management, is moving towards predicting probabilities.
Probabilities. Meaning what?
Instead of just guessing $40,150, the AI would tell you something like, there's a 75% probability the price will be higher than the current price in the next 5 minutes, a 20% chance it stays roughly the same, and a 5% chance it goes down.
Okay. So it gives you odds, not just a single guess.
Exactly. That allows for much smarter decision-making. You're not just betting on a single number being right. You're managing risks based on likelihoods. It shifts the game from pure prediction towards sophisticated risk management.
And why is pursuing those real probabilities considered the ultimate goal for advanced trading?
Because it allows for that sophisticated risk management, moving way beyond just a simple directional bet.
You can weigh your decisions much more intelligently.
Precisely. How much capital do you risk if there's only a 60% chance versus an 85% chance? It changes everything.
Okay, let's try to pull this all together then. If
Yeah.
you had to synthesize the big takeaway from the source material for our listeners.
I think it's this. Trying to predict the long-term market, the weeks and months ahead. That's incredibly difficult, maybe impossible, because it's dominated by unpredictable news, human psychology, big external factors. It borders on gambling.
Right. Too many unknowns.
But predicting the very short term, those tiny one-minute moves driven by the structure of the order book, the mathematical gaps, the sources argue that is actually a solvable problem. It's a mathematical puzzle, not a psychological one.
So the AI isn't some magic crystal ball.
Not at all. It's a powerful microscope.
Yeah.
It's a tool that can perceive and react to these mathematical patterns in the order book that are happening way too fast or way too subtle for any human trader to consistently see and act on.
The opportunity is hidden in the math, not in the news headlines or the fear and greed index.
That seems to be the core message.
And the final thought here. This AI revolution in trading, it's not some sci-fi future. The sources make it clear it's happening right now.
Absolutely. The tools are here. The interesting thing is, the main challenge maybe isn't even writing the code anymore, thanks to these AI assistants.
So what is the challenge?
It's forcing yourself to understand those underlying mathematical mechanics of the market, the order book dynamics, the stuff most people just gloss over while they're watching the ticker tape or reading news articles. That's where the edge seems to be.
So the call to action is what?
Don't be intimidated. Use the tools. Try asking an AI assistant to explain a concept or write some basic code to load some historical price data. Start exploring. The real opportunity seems to be in understanding and leveraging the market's hidden math, and the tools to do that are finally within reach for almost anyone.
Focus on the mechanics, use the assistants, and see what you can discover.
Exactly. Out to row music.